Hello, everyone. Welcome to today's webinar, SingleStore Architecture for Developers, a primer into distributed systems for SQL. My name is Diogo, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower right corner of your console. We will answer everyone's questions after the presentation. After today's webinar, you will receive an email with the recording. If you wish to contact us, please email us at team@singlestore.com. So let me introduce our speaker today. David is a Senior Manager of Education Delivery at SingleStore. Previously, he scaled data science and AI training at Galvanize and General Assembly. David has over a decade of scaling data products, including at Fortune 500 financial services companies, including Deutsche Bank, Citigroup, Aflac, and ADP. Welcome, David. You now have the floor.
Thank you so much, Diego, and thank you so much, everyone. It's great to see you, and welcome here today. Let me see if I get my presentation up on full screen. One moment here. All right, welcome. Everyone should see my presentation as well. So today we're going to talk about architecture for distributed systems. We're going to dive into SQL and why that is powerful on SingleStore. We'll be going through a presentation for about the next 40 minutes, and we'll be having the opportunity to go through some knowledge checks, and we'll be sharing Q&A for the end. So any questions you have, feel free to add those into the chat as well. To get us started, I'll let you know, here is our agenda for today. We're going to focus on architecture on SingleStore managed service, what are aggregators, leaf nodes, and partitions in distributed systems, and why the shard key is a unique filtering object to make distributed SQL possible. Then we'll go into the Q&A as well. So to start us off a little bit about SingleStore, for everyone who's hearing the first time about distributed SQL, we know for a fact that data is continuing to grow, and every business is needing to make insights possible through analytics and through applications. And that's where a product like SingleStore comes in. Our focus is to help teams perform faster results, whether you're data engineers, data scientists, developers, DBAs, or the executives at the CIO and CTO level. Where we are today is SingleStore builds fast analytics and intelligent applications all across the world. And this is a sample of some of the clients we're working with today. And we have three core areas of focus at SingleStore. This is around fast ingest with data pipelines and moving your ETL processes, around very low latency. So you're having near real-time queries for query tuning and performance in SQL, and highly concurrent systems so that your dashboards or applications can support tens or hundreds of thousands of users. And what does SingleStore mean for your company, whether you're a startup, scale-up, or enterprise? It means that you can build modern applications with SingleStore as a database. You can augment your traditional data warehouse if you're using tools like Snowflake or any of the hyperscalers like AWS, GCP, or Azure. And you can modernize legacy systems and replace them with a modern tech stack that scales both horizontally and vertically. Where the SingleStore product is today is as of December 2020, we've released version 7.3, and we're on our roadmap for our 7.5 release coming up in the second half of 2021. Our product today is available on all the major cloud systems, including AWS, Google Cloud, Azure, and Red Hat Marketplace. And we support both a public and private cloud option for scaling distributed SQL. With that as context, we're going to dive into our topic for today, which is architecture for developers, a primer on distributed SQL systems. As a reminder, when you have any questions, feel free to chime into the chat, and we'll be sure to get to those questions on the latter half of the webinar. So let's start with some architecture. At the start and the core of our product, there are three main features that make distributed SQL systems work. These are aggregators, leaf nodes, and partitions. When we look at SingleStore, we treat these as nodes. What the nodes look like is you have a machine. This machine could be your laptop or a terminal. And through that, you can run SQL queries and connect directly to an aggregator or a command plane system. That command plane will run this DDL or DML command and process it directly onto your worker nodes or leaf nodes. Those leaf nodes will perform those actions and share the results directly back to your aggregators to roll up the data to you, the user, the actual analytical dashboard, or the intelligent application. When we think about SingleStore from an architecture perspective, there are two main types of aggregators that are used: master aggregators and child aggregators. Master aggregator is your command plane. It's the central zone where all DML and DDL queries are run for node configuration, database configuration, and data distribution. We also have child aggregators so that there's no bottlenecks on any of these processes. And as of our version 7.3, child aggregators support DDL forwarding to the master aggregator. Thinking about building a cloud cluster, here is a simple example of SingleStore at scale. In this simple example, we have 4 nodes, one master aggregator to manage your processes, the child aggregator to facilitate the query DDL commands, and the leaf nodes that can work and process your requests. Every cluster requires at least one leaf node, and that can scale to thousands of leaf nodes horizontally with as much compute and memory as you need for your mission-critical applications. When we think about leaf nodes and data storage, it's important to note that of the 4 nodes we're looking at on this demonstration here, master aggregators and child aggregators, they perform the commands. These are the inserts, updates, deletes, and configurations, but they don't store the data. That is processed on your leaf node. In fact, these leaf nodes, which are bare metal, they're commodity hardware, think of Amazon AMI or Linux machines. These machines are your worker nodes for your database. In fact, these worker nodes are split into what's known as partitions. And every leaf node has partitions that you can customize for your tech stack. By default, that's set at 8 partitions. And this is valuable because this is where the bread and butter comes about distributed SQL. What we see here with these partitions are that the data can be sent to each partition, stored on these leaf nodes, and then the queries are processed. As we're seeing here in this demonstration, this is the best case scenario where you have a uniform, even distribution of your data across the nodes. This is what we're looking for in distributed SQL systems, to build even distribution of data movement and data processing. But to get there, there's a lot of work and a lot of research that we can get into to balance and maintain high cardinality and uniqueness for our data. Now, before we move into a more advanced topic on that, let's do a quick knowledge check on the architecture overview. So from what we just heard, here is the first question to see what do you think about architecture. The first question here, and let me know if this is looking full screen as well. Okay, this should be full screen for everyone. If not, Diogo, just let me know. So the first question is, which of the following work is done by the master aggregator in a SingleStore cluster? The questions are either, is it A, you're receiving the queries from requesters and distributed workleaf nodes, B, storing cluster metadata, C, returning query results to the requester, D, combining results that are returned from leaf nodes. And in fact, it could be multiple of these options. Okay, I think my poll is back on the screen so you can see all those. So this is a multi-select question. We'll give everyone about 30 seconds to a minute to see which ones do you think line up for our master aggregator. Okay, the results are coming in, and we're seeing our live calculations on our view here. It looks like the majority of the participants believe that D is true, that the leaf node results are being returned and aggregated by the master aggregator. This is definitely a true option. Our next most popular response was that the master or aggregator would receive queries and distribute the work to the leaf nodes. Yes, this will come into our next topic on shard keys as the data is distributed among those nodes. But those are not the only two correct answers. In fact, our third most popular choice that we still had an overwhelming response was that we return the query results to the requester. See, the master aggregator for a SingleStore managed cluster is managing the processes of commands, of aggregation functions for our distributed SQL. Now, lastly, here is a part that we didn't cover too much. So if you're an advanced SQL participant here today, you may have caught on that the master aggregator also stores cluster metadata. This, in fact, is quite similar to standard open source distributed systems that we look at in Kubernetes and other SQL systems where you're managing metadata at a cluster level. So for this question, these are all four things that the master aggregator can and does do for SingleStore managed service. Okay, we have one more knowledge check for everyone for your participation. Thank you on that first one for participating. Here is our second knowledge check. So we're going to have one more poll come up, and this one is about which of the following work is done by the leaf node in the SingleStore cluster, about these worker nodes. And similar here, this is the question for selecting all that apply. So there could be more than one option that is correct. Okay, I'm going to get us launched that poll so everyone can check it out. So here we go. The second poll has just launched, and I'm going to bring back on my screen in case it's not showing full screen here. So nodes, the worker nodes do for a distributed SQL cluster. Okay, I see some great results coming in. I'm going to give everyone another 15 seconds here. Okay, so we have some results here, and I'm going to talk through them. So we're going to close that poll out right now. And I think we can share those results as well. So these should hopefully appear on everyone's screen, or I can show it on my screen as well. I'm going to also bring back up the presentation. So what we had here is that the majority of respondents responded on C and D. In fact, D is a true answer. The leaf nodes do store the data. The data is housed in partitions, and then the work is performed on those partitions. But what happens is that the leaf nodes, they perform the work, which means also that answer choice B is true, which means that they return these query results back to the requester. And what is the requester? The requester in this case could be the master aggregator. So this is a little trick response here. Some people said yes, some people said no on B. In addition, C came out as an overwhelming response from everyone. Yes, the nodes do execute queries against the data it stores itself. So once the data is on these leaf nodes, the master or child aggregator will issue a command, and then the nodes will run those queries in parallel in highly concurrent systems. So great selections on C and D, and B, well, it depends on your interpretation there. So I thank everyone for the participation on these two knowledge checks. Now let's take it one step further. The cream of the crop is about sharding and shard keys. This here, this concept is about how SingleStore builds distributed systems with our universal storage. Shard keys is in fact the most powerful knob that you can tune to make queries run faster. And we're going to do a quick primer on that right now. So first, let's talk about this concept known as sharding. What is it? How does it occur? What is this concept of data skew that can be giving us issues for data analytics, machine learning, and advanced applications? And how do you define these shard keys as well? And how do you selectively choose those shard keys? Let's revisit a visualization that we saw earlier. This is of our aggregator. We see here at the center of the page our master aggregator. And this aggregator, in fact, has to make a decision. It has to connect to these leaf nodes with these empty partitions and transfer the data there. But how do you make that data uniformly transfer? Or how does it smoothly get transferred? Well, we have what's known as sharding. So in an ideal world, this transfer would occur to every partition evenly on the leaf node. And that would result in this scenario where we have a uniform distribution of data. This is what we are aiming for as developers, so you can have the best, highly robust and performant systems. Now, in the real world, that's not always the case. Sometimes we have a scenario like this, where we have an uneven distribution of data, where some of the partitions have more data and others have less. The key to know about distributed systems is they are only as fast as your slowest component. So in this case, the different partitions that house more data will slow down the return of the query to the requester. And our goals as DBAs, data scientists, data engineers, and even SQL developers is to optimize and to tune the system to get back to as even of a distribution as possible. Now, let's dive deeper into how shard keys perform and what is the nuts and bolts of that with SingleStore. Well, it looks a little bit like this. Our demonstration here on this slide, you have on the right a table, and the table has 4 columns where we're looking at, let's say, an e-commerce sales table for perhaps a company like Amazon. So you have different orders, you have customer IDs, order dates, and status. And you want to take this table, which is more than the 16 rows that we see here. In fact, a table could be millions, billions, or trillions of rows, but we're keeping it simple for this scenario. And you're wanting to distribute that data to the different partitions to run against as a query. So we would take a column to be this shard key or this distributed key. So at SingleStore, we have a specific name called the shard key, which is a column that you set that you believe as a developer has high cardinality or high uniqueness. In fact, it's as close to a uniform distribution as possible, where there are no duplicates or minimal duplicates, so that you have even distribution. In the case of this scenario, our order IDs happen to all be unique. In fact, we have 16 of them starting at index 0. In fact, our partitions start at index 0 as well. And these 16 of them can distribute across each row segment. In this case, we have 16 row segments that are being distributed into our partitions. So in this case, you would perhaps consider that this is great. This is a good uniform distribution, but also, would this always be true? Part of the work as a developer is optimizing and tuning your queries to know when a shard key is ideal and when one is not providing you the best performance. So let's say if instead of the order ID, we chose the customer ID, how would that distribution look like? It would look a little different. So in this case, the customer ID column, there are some data points that do overlap. And when we distribute across all that data, what we see is a little bit more going on here. We've circled them with different colors so you can see how some of the partitions actually house more data. In fact, in this case, partition 12 will end up being that bottleneck, and some don't house any data at all. So this is actually known as data skew. This, in fact, is a close proximity to what actually occurs under the hood with SingleStore when you're building fast analytics and intelligent applications. We have algorithms that run behind the scenes on the aggregators that hash through these values, and they're mapping the hashes to specific partitions. Now, as we see in this scenario, the data is not uniformly distributed. This means the data skew is already appearing today. And as a developer, your goal in an SQL editor, such as the SingleStore Studio managed service, is to minimize that data skew as you're looking through your schemas and building tables from the onset with a robust shard key. Taking this all together, let's review some of the best practices when working with shard keys. First, there are some goals to consider. You're looking to build even distribution with as little skew or no skew as possible. In an ideal world, shard keys are accelerating the movement and the processing of data, whether this is through pipelines, whether this is through integrations and connectors with BI tools like Tableau, Power BI, and Click, or whether you're building intelligent applications that might be streaming real-time ads, real-time COVID predictions in the marketplace, or real-time distribution of scoring models and scoring results back to the users on social media platforms. This is where a shard key helps out. It accelerates the use of your data and the query performance. A lot of times we'll have companies come to us and say, hey, we use PostgreSQL, we use MySQL, we're using a lot of these open source tools and we want to get faster. And that's where a shard key and the distributed technology at SingleStore can help you out. When you're thinking of building a shard key, there's a few other notions to consider. First, you'll be wanting to choose a shard key that has high cardinality or uniqueness, as few duplicates as possible. Think of this as a primary key. Secondly, you'll want to choose a shard key that matches the field that you wish to group by. Because what happens is your master aggregator are running these DDL commands, moving the data to your leaf nodes, and then performing the calculations on every partition for that query, which is about aggregate functions. We're first splitting up the data, running the operation, and aggregating it back together. So shard key is very important when you think about aggregations and group bys. And thirdly, think of shard keys to match fields that you will be joining on. So whether you're running inner, outer joins, or any types of joins in procedural SQL, like user-defined functions or stored procedures, shard keys will give you significant performance improvement when you're running your join commands. Well, that was a lot of information to digest on shard keys, and this is going to lead us into our next knowledge check to see which parts map up to your knowledge. So let's do a quick review on sharding and shard keys. Here is our next knowledge check for today. Which of the following best describes what a shard key is? For this question, there is only one correct answer. So which one is the best correct answer? I'm going to open up the polling as well. So we're launching a poll, and I'll get this back to our full screen. Okay, so which one is best for a shard key? Is it a column or columns that's used to determine the partition that incoming data will be stored in? Is it a column or columns that's used to segment the data in the column store? Is it a column or columns used to define and enforce the relationship between two database tables? Or is it a column or columns that identifies a row as unique within the database table? Okay, we'll give everyone another 15 seconds on this question. Okay, let's see how everyone voted here on the question. Gonna close the poll, share the results. So we have mixed results here. It looks like A and D came up as our two most common responses. Let's review from the question and see which one's correct. I'll tell you, it's one of those two. So thinking of the shard key here, let's first see why is B and C both incorrect. Okay, is a shard key a column or columns used to segment data in the column store? Well, today we didn't talk much about our row store and column store data structures, with column store being the default data structure as of SingleStore version 7.3. We look towards universal storage, and we do note that the shard key, in fact, helps not segment the data, but move the data, right? So this is why B is wrong. It's not actually just segmenting it. How about C? Is it a column or columns that defines and enforces the relationship between two database tables? Although the shard key can identify how to distribute joins quicker and more efficient, it's not exclusive for two database tables. So C is not the best answer. So now when we're looking at answer choices A and D, what's distinct here and which one is correct? Well, looking at answer choice A, a column or columns that's used to determine the partition that incoming data will be stored in, a shard key does help with the movement of data into the partitions, but does it actually determine the specific partition? And how about D? A shard key is a column or columns that identifies the row as unique with the database table to then move and distribute the data across. So you can see how A and D both sound pretty good, just which one's more accurate? In this case, the answer is actually D, because what happens for the shard key, as you might recall, is we're moving row by row. We're moving through row segments, then identifying those unique identifiers for the column, for the table, and then distributing. So the shard key is this hash algorithm to identify uniqueness, identify high cardinality, and then the master aggregator performs the action of the movement of the partition. So in an aspect, all four of these are definitely on for what shard keys do, but answer choice D is the most accurate here. So great participation on that question. All right, we have a few more concepts I'm going to cover over the next few minutes, and then we're going to open it up for Q&A. So as you're having any questions, I'll just remind you, feel free to add them into the chat, and we'll be going into them in just a few short minutes. So there's a few concepts here that I just talked about that we haven't gone in depth onto that I'd like us to explore, and this particularly is about where is SingleStore as a product today. So traditionally, SingleStore was a dual store product. In fact, where we had in-memory row stores for hot data, for transactional operations, concurrent updates, with fast SLAs with few millisecond responses. And we had on-disk memory for the column store, which was for analytics, like these dashboards with Tableau, Power BI, Click, SciSense, and other tools for archival historical data that can scale into the petabytes and beyond, very high compression. With our most recent release of SingleStore 7.3, we now have universal storage. And what this does for developers is it simplifies your architecture. You have a lower total cost of ownership, and you have lower latency because we've been providing performance improvements to make column store not only the default, but to ensure that you're getting the best of query performance, both for in-memory and on-disk data. Where SingleStore is today is there's a lot of benefits if you're just getting started as a startup, scale-up, or enterprise. First, around ingest. So if you're bringing data in, if you're using Kafka pipelines, if you're loading data from any fast data store, you can perform those transformations. You can use many of the common programming languages that you work with today, such as Python, R, SQL, Java, Node, and others. And then beyond bringing in your data or augmenting it with universal storage, there's many areas that you can run with the SingleStore product. So we are running on the cloud, in every cloud and everywhere. That's where we have SingleStore managed service. But depending on your architecture as a company, we do support a K8s, open containers. We have self-hosted cloud if you're a company that doesn't run on public cloud. So we have a private cloud. And we also have on-premise solutions as well. So you can run our database anywhere to scale your analytics and applications. We have these fast analytics. They're the dashboards and BI tools that were mentioned. Could be ad hoc queries that an executive or team member wants to run against to see any change in data movement, and predictive machine learning. We've been seeing strong use cases there today where with different mobile applications, companies are speeding up the process of on-chip and in-memory ML as well. And finally, on fast applications. So, as an executive and as a client, you want real-time decisions. And if you have other tools that you're using that are taking you a few minutes or a few seconds, shaving that time down to milliseconds can be all the difference in maintaining your customers and not having any churn in the marketplace. For the IoT space, smart chips, there's so much data out there, and processing in real time can mean the difference between a system having uptime or having downtime. And of course, dynamic experiences. When you think about systems at the airports today and on our different vehicles to measure if someone has a fever or if they are the identity that they're confirmed, systems like SingleStore can speed up and accelerate that to make for seamless user experiences. Lastly, before we open it up for Q&A from the audience, in general, if you're looking at SingleStore for the first time, you can turbocharge your web applications, your customer experience, dashboards, IoT, anything in the ML space like anomalies and insights. And if this is your first time or you're a seasoned learner with a SingleStore product, you can learn your own way. So there's a few ways you can continue to learn more beyond this workshop. We're going to be having additional webinar series, especially with education and SingleStore University, that you can tune into these as we continue to have them every month. You can also learn by reading by going to docs.singlestore.com, engage with your peers in the community at singlestore.com/forum, learn by watching with our technical evangelists. They run series on youtube.com/SingleStore and on Twitch, and learn through training with both self-paced and in-person training at training.singlestore.com. If you're new to the platform, you can get $250 in free credits at the singlestore.com/managed service trial with hyphens there in that link. And you can use our product today in production with singlestore.com/download. Our upcoming events that we have, and then we'll open up for Q&A, so feel free to have questions on the chat. We have 3 more events coming up in the next couple weeks. On April 27th, we're having a virtual event on JavaScript tests in Node, the browser, and with continuous integration. You'll be joined by Rob Richardson, who is our internal technical evangelist. Also on April 27th, we'll be covering 20 times faster analytics with data warehouse augmentation. And on May 4th, we'll be having a webinar series on modernization of first-era systems if you're migrating from an open SQL system like PostgreSQL. So we have those coming up. And now let's dive into any questions that you may have that we've been covering today or anything around distributed SQL. Okay, looking through some of the questions here in the chat. One question is, there's a lot of distributed databases. Why should I consider using SingleStore? So when you look at distributed databases, usually they answer 1 or 2 of 3 questions well, but not all 3. They're usually good at ingest, they might be good at query tuning, or they're good at concurrency. But heads up, when you look at all 3 areas, these are all addressed by SingleStore, and there are not many distributed databases that are actually working at all 3. Also, our product is constantly including enhancements, especially in our next major milestone release, where we'll be having bottomless storage, we'll be having a continuation with separation of compute and storage, and we'll be diving into also further recovery options to accelerate high availability and disaster recovery. So if you're considering a solution, I recommend you check out our product, connect with our solution engineering team. We'd love to show you how SingleStore could work and create a solution for you to scale your business needs. Okay, we have a few other questions coming up on our product enhancements and our release cycle for our product. So for everything around SingleStore, we do have a docs.singlestore.com where we do share our latest release notes. And we're now at 7.3. We've been having monthly maintenance releases coming out. So we've recently added additional benefits, such as the DDL forwarding from the child to master aggregators, and additional improvements that we're accelerating into 7.5. One of the questions here is around foreign keys. This is definitely on our product enhancement roadmap that we're looking towards, and this will probably be later in 2021 or early 2022. We have another great question here about the product roadmap with different OLAP cubes on big data such as Apache, Keylin, and Pinot. Yes, I can't speak specifically to those 2 OLAP cubes, but we are adding new connectors and new integrations every single day at SingleStore. If there's an integration that is mission critical for you that you'd like to see for our product, please drop us a line, and we're happy to share with our product management team so we can prioritize that for the enhancements in the product. We're always adding new integrations that are going live so we can make your workflows more seamless and more scalable. We got a great question here. It's saying that if you're redesigning your architecture and moving to microservices, how would you work with SingleStore? Would you have one SingleStore cluster? Would you have multiple clusters? Would you have one database? Would you have multiple databases for your tables? So every SingleStore cluster can have as many databases as you want, depending on compute and memory. And depending on how you horizontally and vertically scale that, with the amount of queries and concurrency occurring, is whether you'd want that on one cluster or more. This will depend on your use case. In general, for disaster recovery and high availability, all nodes are duplicated so that they can prevent any downtime and ensure high upkeep for your systems. Also, there's replication available to further keep those systems secure. When you're thinking about building multiple clusters, in fact, just getting started with the low levels on our SingleStore managed service, I think you can be quite surprised about how effectively SingleStore can help accelerate your different workloads. And if you're someone who's already working with a big architecture at your company and you're not certain if you're ready to replace it yet, I'd say you can augment your architecture with SingleStore. Take some of your non-mission critical workloads, throw them on a SingleStore cluster, see the performance hand in hand. And as you start seeing that acceleration and results, you can start to move additional queries and then consider bringing on mission critical workloads at the comfort to help your organization accelerate your analytics and the workloads that you need to be successful. Okay, we have another question here about SingleStore Studio, which runs in the SingleStore managed service. The question is, can we check if partitions are evenly distributed? Yes, so we have several SQL commands, including the explain and profile commands that can help you see how data is moving from your master aggregators to your leaf nodes. And we also have an information schema table that stores events. You can see these events for different views, both from the master and the leaf nodes, and actually look at the compute and memory on a query performance on your system. So when you're running a live query, you can profile that query and see how it's running on your nodes, and if that's evenly distributed. If that's not, you might do some additional unit testing, changing up your queries, changing up a shard key, or performing other operations for your cluster, such as rebalancing, adjusting partitions, or expanding compute as well. We have another question about, is there a latency between memory and disk? So in general, in-memory has historically been very fast for hot data, for transactions coming in live in real time. And we're excited that as of 7.3, we've brought many of those best performance improvements also directly to column stores. So column stores today do support the same query performance benefits that we've seen in row stores. Of course, we do have an in-house solution engineering and DBA as a service team that can help you refine and improve the results depending on your workload. Beyond that, when we look at latency, typically there's less latency on the SingleStore systems. It's more on the network IOPS and the network systems with existing architecture. So we always recommend, companies to see how they can improve that, and we provide different recommendations to help you improve your architecture as well. Okay, we have another question here. What happens if one leaf node is down? Is there built-in replication? What happens here? Well, by default on SingleStore clusters, there is high availability, which means every leaf node is duplicated and that there is data running on both levels of each of those nodes, which means that one is inactive. Basically, one's a primary and one's a secondary. So if a leaf node goes down, there's actually a process where the secondary leaf node would become the primary, and then the primary leaf node would actually restart and come back from offline to an online state. And with high availability, this is completely automatic. In fact, there's never downtime for your data because of the leaf node replication with high availability. Now, beyond setting up HA, there's also pure replication, where you can actually create a complete replication of the cluster and all of its data as an additional backup in an availability zone on the cloud. So there's multiple techniques available to help with recovery and ensuring that you never have any downtime for your systems. Another question is, how do we write queries in SingleStore tables? What would this look like? So SingleStore is MySQL wire protocol compliant. This means if you've run any commands in MySQL, all those commands are 100% supported. Everything from stored procedures, user-defined functions, table-defined functions, or any of those flavors of SQL that you've worked with. In addition, we do have SQL documentation that dives into all the commands that we support, and the built-in ones particularly engineered by our SingleStore engineering team. Okay, we have another question here about what is the advantage of SingleStore over Snowflake. So Snowflake is great for storing data. It's great for building out an entire data ecosystem. However, one of the differences we see when we come head to head against Snowflake is first total cost of ownership. When you're looking at mission critical workloads that scale, the Snowflake solution can be quite expensive, and typically our results do come significantly under the cost that you would spend on a system like Snowflake. Also, when we look at Snowflake and SingleStore, particularly SingleStore accelerates at all three areas, which were meant about the ingest, the query tuning performance, and the concurrency. Snowflake doesn't necessarily win at all three areas. So it does depend on your workloads. We've seen a lot of clients who find Snowflake above their price point come to SingleStore to augment their data solutions, see some good use cases that work, that help them out, and then they further move additional workloads over. And I think, if that's something you're exploring, our solution engineering team is happy to facilitate that for you as well. Another question is, does SingleStore support transaction atomicity? Yes, we do. We do support that today. Another question is, what can SingleStore share regarding ingest, query speed, or rate? It does depend on the workload. We've done different workloads where we can hit over a 1 trillion rows per second. So it really depends on the specific use case, even ones with, millions of rows for upserts. So it depends really on what you're trying to build. And, our team can show that for you. We do regularly blog at singlestore.com to show different metrics and benchmarks as well. And we believe that, if we can chat more with you, we can share with you those benchmarks depending on the workloads that you're looking at. Oh, thanks so much. I heard that someone said in the video, you can see the little pet behind me as well. So that's a great little dog. And I'll tell you that although she doesn't program in SQL, she does love hearing about it. So, or at least maybe I put her to sleep today. But thanks so much for that comment. Another question is, does SingleStore have any enterprise management tools for developers? So SingleStore can run both on cloud and not on cloud. From a developer perspective, we have our SingleStore Studio, and SingleStore Studio includes the SQL editor, includes the Visual Explain tool, includes different logging and auditing techniques as well, and can also be run from the command line. You can run them directly from integrations with your analytical tools like Power BI, Tableau, and Qlik. You can also run it from a standard command line on your master aggregator, where you can run different operation commands for SingleStore toolbox. And we have all those in our documentation as well, so you can manage, operate, and further administer your clusters as well. We have a question here about partition count. So if today the partitions are set as 8, can that be changed over time? Yes, that can be scaled up. So if you'd like to scale up the partitions, you would go through a process where you would say, maybe I'd like to do, let's say, 16 partitions, and then you would rebalance those nodes so that the data would still be distributed evenly. When you would initially change from 8 to 16, you might have data on 8 partitions, and 8 would be empty at the onset. But with a rebalance command, then you would get that all balanced out. Okay, and there's a few more questions coming in, so we still have a few more minutes. So any additional questions, feel free to bring them in to the chat, and I'll do my best to see how I can respond to these for you. And as a reminder, beyond the questions, I'll just bring back here on the screen, as you're continuing to look to learn more, definitely check out our docs, our forms, our training, and the YouTube channel. And I've really enjoyed walking everyone through this workshop on distributed SQL with SingleStore architecture. But happy to go through more questions, so feel free to bring in more into the chat. There's another question I see here about different connections, whether these are for OLAP, cubes, or other functionality. So a couple other things I can note is that we are working on supporting native drivers for some of the traditional systems like JDBC and ODBC. So we do have a product roadmap that does include additional support. If one on OLAP cubes is something mission critical for you, definitely please share with our team, and we can see how to prioritize that as well.
Hey, David, I think we ran out of time. I want to thank David for the presentation. Thank you for attending the webinar today. We will send you a follow-up email with today's recording and a link to our managed service free trial. We are offering each user a $250 in credit, so you can start a full workload today. Lastly, check out our other virtual events at SingleStore.com. www.singleStore.com/events. And thank you for joining us, and have a great rest of the day.
Thank you, everyone. If you have further questions, please feel free to reach out. And thanks so much for joining us today.